exponent rules. So we have a couple different things going on with exponent rules. They can be a little bit overwhelming, but this is why we've kind of been going slow on the homework assignments. And I just want to remind you, I'm not giving you homework assignments to just like give you a bunch of work to do. Especially with these exponent rules, like you just have to practice them. And that's the thing with math is you get good at math and it sticks in your brain the more practice and repetition you get. Okay, so I know it may seem like it's a lot of homework, but it's only like 4 to 10 questions, and so it's just going to help you. Okay, all right, so these rules are on your EOC formula chart, so you'll have access to these when you take your STAR test, so you don't have to memorize them, but you do have to understand what's going on. So the first one that we have is product of powers. So product is the answer we get when we multiply. Okay, so this is when you multiply. For instance, yeah, of course, Dominic. So any of the assignments in Class Kick, you can go in and revise and edit, and you just have to do it before March 19th, and you can always earn up back up to the 100. Okay, so multiply. When you multiply exponents, you're going to multiply the coefficients in front. The base is going to stay, and multiplying means you're going to add the exponents. Okay, I'm going to show you why we do these in just a minute, but I just want to go through these really quick. Quotient, that is the answer to a division problem. So this is going to be when you divide. Maybe. Okay. When you divide, your base is going to stay the same, and you're going to take the top number and subtract the bottom exponent. Then we have power of a power. So when you take your exponent and raise it to another exponent, that is when you're going to multiply the two numbers together. You don't really need to know the rational exponent. If you get an exponent that has a fraction in the exponent place, you can just follow this rule here. Your base stays the same. Your m, the top number, your numerator, is going to stay under the little radical house. Okay. And then this one is important, the negative exponent. If you have a to the negative n, or let's say it's x, do an example here. I think that this one is easier if you see an example. X to the negative third. This would be 1 over x to the positive third. So that negative becomes positive when you move it to the bottom. Now, the other way is, let's say you had 1 over x to the negative fourth. Again, we want to get rid of negative exponents. When we move it to the top, it becomes positive. So that would be x to the fourth. Okay, I know this seems like a lot, but I'm going to go through and do some questions with you. So if you would grab a piece of paper. This, actually, let me see if I have some. Those are power over power. I thought I had some multiplication first. Maybe not. Okay. Let's do this. I'm going to pull up a blank page. If you will go to your 0A.12 homework in Class Kick, I want to show you why when we multiply exponents, why we actually add the exponents together. So when we multiply exponents, first of all, let's do a quick review. X squared is x times x. Okay, this has an exponent of 1 and 1. So x times x is x squared. 1 plus 1 is 2. Okay, so that's how we get that x squared. This product rule is just kind of working backwards. So let's say I have x squared times x to the third. Okay, so that would be x times x, that's my x squared, times x to the third, which is x times x times x. I have x times itself 5 times, and 2 plus 3 is 5. Okay, so hopefully that kind of helps you like solidify a little bit of like why, even though we're multiplying, we're going to add the exponents. But what if we have some coefficients in front? So let's say we have negative 2x to the fourth times 3x to the third. So again, our exponent rule is going to stay the same. We're going to add 4 plus 3, so it's x to the seventh. For the coefficients, these are regular numbers, okay? They're not exponents. They don't have special rules. You're just going to do 2 times 3. Sorry, negative 2 times 3. So you would get negative 6x to the 7th. Okay. In class kick, one of the tougher ones, I'll do let's do number 9 together. I'm gonna do it on the board here, but go ahead and you can work out number 9 in the homework. Caitlin, you have to log in to your profile. I think I sent you an email about that. There is no link or code. You just go to classkick.com. It's called 0A.12. I'll write that on the board. Yep. So 0A.12, and we're going to do number 9 together. So it says negative x squared times 5x, negative 5x squared times 2y to the fourth. So if you remember back, I got negative 6 on the previous slide, Adelina, because I did negative 2 times 3. So when we do adding and subtracting polynomials, we can't add or combine things unless they have the same base, the same variable, and the same exponent. But multiplying is different because we can multiply them together. We just only add the exponents of the like terms. Okay, so you'll see what I mean in this problem here. What I like to always do first is just go ahead and multiply out my numbers. So this would be a negative 1 times negative 5. So negative 1 times negative 5. And you can do this in 2 parts if that helps you. Negative 1 times negative 5 would be positive 5. No, we're not adding. Negative 1 times negative 5 is positive 5. And then, sorry, Paulina, after we do that, we are going to take our base, so x, we have x squared times x squared. So 2 plus 2 would be 4. So we'd get these two multiplied together, give us 5x to the fourth. Yep, Liv, it's right here on the board, sweetheart. Number 9. Yes, Richard, negative 5, you're good. Negative 5 times negative 1 is positive 5. A negative times a negative is a positive. Now, Caitlin, I don't want your answers for the homework in here because I still have to go in and grade it. Okay, so write it on your class kit. All right, then I still have times 2y to the fourth. So again, I'm going to do the numbers. 5 times 2. 5 times 2 gives me 10. X to the fourth, y to the fourth. Those, I don't add those exponents because they're not the same variable. All right, I'm going to make up another problem for us to practice. So let's say this is not on the homework. This is just one I'm going to make up, and then we're going to go on to dividing. So let's do negative x to the third times 4y squared times negative 3x squared y squared. There you go, Dominic. Okay, so if you want to try to do it all in one step, oh, where'd my problem go? You can. Shoot. Hold on just a second. My computer is freezing up. Can y'all see anything on my screen? I don't think you can. Okay, there we go. All right. So -1 times 4. That would be -4. Oops, let me make that bigger. -4 x to the third y squared. Okay, this is the answer I got when I multiplied those two terms together. Now I'm going to rewrite the rest of my problem. So now I'm going to do the numbers first. So -4 times -3. That's going to give me a +12. I do have x's, so 3 plus 2 would be 5, and y would be 2 plus 2, which is 4. So that would be my final answer. Okay, I want to move on to dividing. Liv, did you watch the video in yesterday's lesson? I really can't slow down because we're trying to get through all of this in the next 15 minutes. Okay, but you can go back and watch this recording and like pause it if you need to. Do you have questions about this one before I go on to dividing? We're going to have another small group over this tomorrow at 9 and at 10. Okay, and then don't forget you have every day in the course, you have videos that you watch and they go a lot slower. Okay, so don't forget that you still have to watch those every day. Okay, let's go. Okay, so let's talk about dividing. So when you divide, let's say we have x to the 6th divided by x squared. Okay, x to the 6th, I'm going to show you why we subtract first, is x times x times x times x times x times x. Okay, x squared is x times x. So what we can do if we have the same x on the top and bottom, we can cancel these out, and how many x's on the top am I left with? How many times am I multiplying it? X to the 4th, which is the same thing as 6 minus 2. Okay, so let's try another one. We're going to do another simple one. If I have let's do x to the 4th, y to the 7th, divided by x squared, y squared. Okay, there are not, there's 4 x's after I eliminate one from the top and one from the bottom, one from the top, one from the bottom. So I can cancel those out because I have one on top and one on bottom. So now I have nothing left on the bottom and 4 x's left on the top. Good question. Okay, so now what we're going to do is take our x base, okay? The bottom one's x squared is x times x. I was just showing you why we subtract. If you were wondering why when we divide exponents, why we subtract the exponents, I was just showing you why. You don't have to do that step. That's not a required step. I was just showing you where the rule comes from. Cool. So I'm going to put my variable for x, and x is going to be 4 minus 2, so that would be x squared. Y is 7 minus 2, so that would be 5. X squared, y to the 5th. Yep, x squared, y to the 5th, exactly. Yes, Anya, you're exactly right. All right, I'm going to do another one. I'm going to get just a little bit harder. Let's do 10x squared. Okay, that's a 3, y to the 3rd. Okay, so first things first, let's do our numbers. What is 10 divided by 2? That would give us 5. X squared divided by x to the 4th. So 2 minus 4 is going to be x to the negative 2. It has to be top minus the bottom. And then I'll show you what we're going to do next to get rid of that negative. And then for the red, 6 minus 3 is 3. Okay, so now we have 5, x to the negative 2, y to the 3rd. But we don't want negative exponents. If we look back to our exponent rules, to get rid of a negative exponent, if it's on the top, you move it to the bottom and it becomes positive. So the 5 is going to stay, the y is going to stay, but our x squared is going to move to the bottom. Questions about anything in this problem? Yep, exactly, Anya. It moved to the bottom because it was negative. So, Richard, we are only subtracting the exponents. If they're just plain numbers, we're just going to follow regular math rules. So this is 10 divided by 2. The addition and subtracting of exponents only applies to the actual exponents themselves. Good question. Okay, let's do one more rule that you learned, and then we're going to do some of the harder problems where all three are tied in together. So the last one we had was the power to a power rule. So we had x squared squared. Okay, so this would be x times x. Actually, you know what? This is a really bad example. Hang on one second. I'm going to do this to the 3rd. No, I don't want to use 2. Okay, hold on one second, because this, I want to make sure that you can see this pretty clearly. Okay, we'll do this. So Dominic, it says x times x times x. That would be 3 times. So you're putting, if it was x times x times x, like this, that would be x to the 3rd. Good question. Okay, so power to a power. We have x to the 3rd. Okay, so that would be x times x times x. This is x to the 3rd. And then it's multiplied by itself. So times x times x times x. Okay, how many do I have here? Well, now I have 6. 2 times 3 is 6. So when you have an exponent and it's raised to another exponent, it's squared. I'm sorry, it's multiplied. This one is squared, but it's, you multiply the exponents. So what if I had x squared y to the 3rd raised to the 4th? So I'm going to have x, and then I do 2 times 4, which is 8, 3 times 4 for y, which is 12. Okay, let's make it a little bit harder. What if I add a coefficient in there? So if I have 3x to the 3rd, hold on, y squared, and all of this is going to be squared. So Richard, this is kind of where you were getting confused. Here you go, Adelina. X to the 8th, y to the 12th. Okay, this is where this can get tricky. We have a number, coefficient. The coefficient gets squared like normal. The coefficient does not go 3 times 2, okay? Because 3 squared is not 3 times 2, it's 3 times 3. So you still have to apply the exponent to the number. 3 squared is 9. Then we would have x to the 6th, y to the 4th. So the 3 still gets squared. And if you need to write it out, that's okay. If you need to write it as, okay, 3 squared, x to the 3rd squared, y squared, squared. If you need to write them out separately so you don't get confused, that's okay too. All right, let's try one. Let's do 2 x to the 4th y, and we're going to raise that to the 3rd power. So I want you to try to do this one on your own real fast, and then we'll put it all together for a couple examples. So you need to ask yourself, what is 2 to the 3rd? It's not 2 times 3. So we have 2 to the 3rd, x to the 4th raised to the 3rd. And then y, remember that's an imaginary 1 exponent, okay? Yeah, AJ, what's your question? Sarah, that's an email question, and I grade all the homeworks on the day that they're due, and then after that I just update them like every 2 or 3 days. I have 184 of you, and all of you did like 8 emails. So, okay, that's fine. That's great if you sent an email. Perfect. That's all you need to do. I can't go grade it right now. But I will grade them on the day that they're due. So if you turn it in on time before 5 p.m. on the day it's due, then it gets graded that day. Okay, so AJ, we will go over the quizzes. Like if you want to come tomorrow morning at 9, first email me the questions you don't understand. So go back in and look at your quiz. Email me a screenshot of the questions that you don't understand how you got them wrong. Okay, and I'll go over that with you tomorrow. Okay, we're running out of time today because I just wanted to teach everyone this, since it seems like there was a little bit of confusion. Maybe we didn't watch the video, whatever the confusion is. Tomorrow, we're going to have 2 hours, 9 to 10, well, 9 to 9:45 and 10 to 10:45. So we'll have a ton of time for me to give individual instruction and feedback. Okay, so 2 to the 3rd, that's 2 times 2 times 2, which is 8. This would be x to the 12th, y to the 3rd. All right, I'm going to do one more problem that's kind of like from your quiz where we add all of these rules all together at once so that you can see what it looks like. All right, let me go back to my slides. I think there was a good one in here. I got 12 because 3 times 4 is 12. Perfect. Let's do this one. Okay, so which expression is equivalent to 36 x squared, or sorry, x to the 4th, y to the 5th, divided by 3, x, y, all of that squared. So just like our regular order of operations, we need to follow that PEMDAS, okay? So we need to get rid, we don't have anything in parentheses that can be simplified, but this squared at the bottom, all of that is being raised to the 2nd power. So I'm going to rewrite this top, x to the 4th, maybe, y to the 5th. Let's handle the bottom first. So what is 3 squared? Well, 3 squared would be 9. Then we would get x squared and y squared. Does anyone have any questions about how I got x squared, y squared, or that 9? Okay, cool. Now is where I can start simplifying. So now I would say, okay, what is 36 divided by 9? That would give me 4. 9 is 3 squared. So down here, it said 3xy squared. So that's 3 squared, x squared, y squared. And 3 squared is 9. Good question. All right, now I take my base of x. So I do 4 minus 2, which is 2. For y, I do 5 minus 2, which is 3. Okay, so sometimes you have to do the power rule, like you'll do the product rule first, then division, then multiplication. I don't know. Let me see if I have one more kind of tough one where we have multiple steps. There was one on the quiz. Actually, let me just see if I can find it real quick. I'm gonna write it on the whiteboard. I'll go over just a minute here. There we go. Okay, so I'm gonna show you this one. This one was actually on the quiz. Let's see. So it's 12 m to the 5th, w to the 6th. Let me get a new board here. All right, 12 m to the 5th, w to the 6th, divided by 3w to the 4th. And then this was multiplied by 5m to the 4th, 3rd. Divided by, and then I think it was a negative on the bottom. Let's see. W to the negative 3rd. Okay. All right. So this is one of those where there's a lot of steps. Okay. The first thing I'm going to do is on this left side here, I don't have any exponents or negatives that I need to get rid of. I'm just going to go ahead and simplify this. So I'm going to do 12 divided by 3. I'm going to do the m to the 5th just stays. There's nothing to subtract. And then I'm going to subtract these w's. Alrighty, so 12 divided by 3 is 4. M to the 5th, w squared. Now, on the right-hand side, I have to handle this negative 3 and this m to the 4th. It's the only thing, but m to the 4th is being raised to the 3rd power. So let's go ahead and rewrite that. So that would be 5 m to the 12th, w. Now it becomes positive 3 because I moved it from the bottom to the top. It's not, it's w squared, Amara, because this is w to the 4th, and we have w to the 6th divided by w to the 4th. So 6 minus 4, that's supposed to be a 4. 6 minus 4 is 2. Good question. So now this problem becomes multiplication. So 4 times 5 is 20. When I multiply exponents, when I multiply polynomials, I add the exponents. So for m, it's going to be 5 plus 12, which is 17. For w, it's going to be 5. So Dominic said, so no matter what, whether a negative exponent is moved to or from the denominator, it flips. Yes. So if there's a negative on top, you move it to the bottom and it becomes positive. In this case, we had a negative on the bottom and it moved to the top and became positive. Good question. Okay, I'm going to pause.